So hello everyone. Today in this chapter we are going to talk about the acid, bases and salts. Okay, so let's start. So basically first of all we need to know what do you mean by bases, what do you mean by acid and what do you mean by salts. Okay, so this is our basic question, like what do you mean by acid, what do you mean by bases and what do you mean by salts. Okay. So basically, we could say that by the simple definition, like an acid is a substance, forms hydrogen ions or H plus ions when dissolved in water, whereas base is a substance that form hydroxide ions or OH minus ions when dissolved in water. Okay, it is a basic or the simple definition of the acids and bases which you can got. Okay, and acid and bases react together to form salts. Okay, we will learn about them in detail in this lecture. So let's start. First of all, for the acid. Basically, regarding acid, we have three main theories. First is of Arrhenius theory. Second is of Bronsted and Lowry concept. Then is Lewis concept. So here are three concepts which we need to learn about the acid. Okay, first of all, Arrhenius said that acid forms H plus ions in aqueous solution. Okay, so Arrhenius was the one who said that acid form H plus ions in aqueous solution. Got it? Then Bronsted and Lowry said they donate proton. Okay, and Lewis said acid recept electron. Got it? So basically Arrhenius, Bronsted and Lowry concept and the Lewis concept, they having their definition about the acid. Like Arrhenius said, acid is the one which form H plus ions. H plus ions in aqueous solution. And this was said by Arrhenius. Got it? After Arrhenius, there are three more people. Then Bronsted and Lowry. They said if this is an acid and it having a positive charge, which is the proton, so they will donate it. Got it? So acid donates proton, not protein. Got it? Thereafter, the next is Lewis. Lewis said if this is an acid, then it will attract negative particle, which is electron. Okay, so these are the theories given by Arrhenius, Bronsted and Lowry and Lewis. Got it? Now, what about base? For the bases, they also gave them theories. These three people also gave some theories. Let's start with Arrhenius first. Then comes Bronsted and Lowry. Then come Lewis. First, Arrhenius said that base, it is for the base, remember, forms OH minus ions in aqueous solution. In aqueous solution. It was said by whom? Arrhenius. It was said by whom? Arrhenius. Okay. Whereas Bronsted and Lowry said it accepts proton. Okay. And Lewis said it donate electron. Okay. So did you notice something? Yes. Like Bronsted and Lowry and Lewis said that acid donates proton, and Lewis said acid accept electron. But in the base situation, it gets reversed. Like they accepting proton and they donating electrons. Got it? So this is about the Arrhenius concept, Bronsted concept, and Lewis concept regarding acids and bases. Okay. Now come to next points. It's like acid having a sour taste. Acid having a sour taste, whereas base having a bitter taste. Base having a bitter taste. Okay. But can you taste anything? Can you take a sip of anything? Like if there are three solutions. Okay. And I ask you, just find out which is acid, which one is base, and which is normal. Then what will you do? Will you starting drinking them one by one to find out taste? Like if it is tasting sour, then it is a acid. If it's tasting bitter, then it is a base. And it's tasting nothing, then it's a normal. Would you do? No. Generally we can't. Okay. So how do we find out that whether the thing is acid, basis or normal thing? For this, we have developed some indicators. We have developed some indicators which are in form of three indicators. Natural indicators, artificial indicators, and the third one is olfactory indicators. So these are the basic three indicators which we use to locate whether the solution placing in front of us is acid, is basis, or it's normal. Got it? But in this chapter, we are going to talk about particularly only acid and basis. Okay. So let's start. First of all, the natural indicators. The natural indicators. Okay. So what are the natural indicators? What are the natural indicators? Like the natural indicators basically involve litmus paper, then they involve red cabbage, not garbage, red cabbage, and then turmeric. So these are the three natural indicators which we primarily use to find out whether the thing is acid or basic. Okay. And how do we do? Let's start. For litmus paper. For litmus paper, for acid, for base. For acid, we generally use blue. For base, we generally use red litmus paper. Okay. So whenever, suppose it's a beaker in which substance has been placed. Okay. And this will be your litmus paper. Okay. And if you dip your litmus paper into this solution, then what will happen in the case of acid? As I have told you, in the case of acid, we generally took blue litmus paper. So if this blue litmus paper turn into red litmus paper, then it will be a condition of acid. Okay. If the litmus paper which you are dropping into the solution, if its colors gets changed from blue to red, then remember it is an acid. Okay. Now what's about the base? So for base you have taken the red litmus paper. If you pour your red litmus paper into the solution and you find out that this red turn into the blue, then remember it will be a basic solution. Okay. So simply we can say for acid we generally use the blue litmus paper, and if the color of the blue litmus paper get changed into the red, then it is the acid. For base we generally take the red litmus paper, and if the color of red litmus paper turn into the blue, then it is the basic solution. Got it? Now next is our red cabbage juice. Red cabbage juice. Okay, so let's start. Red cabbage juice. Okay, for red cabbage juice, in case of acid or in case of base, what is the criteria? Okay, so basically the original red cabbage juice is in purple color, is in purple color. Got it? So whenever you testing it with the acid, then what will be the effect? It will turn into reddish. For base, it will turn into bluish. Got it? So basically, it is the phenomena with the red cabbage. If you tested red cabbage juice with the acid, then the purple color will be changed into the reddish color. Similarly, if you're testing it with the basic, then the purple color will be changed into the bluish color. And when it happens, remember the thing which you're having, either acid or either base. You could be identified by changement of color. Got it? Now the last one is a turmeric. Last one is a turmeric. In case of acid, case of base. For acid and for base. Okay. For acid, remember, before acid actually, remember, turmeric is always in yellow color. Turmeric is always in yellow color. Okay. So whenever you treated turmeric with acid, there is no change in its color. Okay. No change. But when you turn it into the base, then it will be brownish color. Okay, so basically the turmeric which we generally used in our households is yellow in color, and to test it with the acid and bases, we should remember that during the acid test it does not change its color. Whatever the color will be, it will remain as it is. Okay, but for the basic, the color will be changed from yellowish to the brownish. Got it? Okay, so these are about natural indicators. These are about natural indicators. Now what's about the olfactory indicators? The olfactory indicators. But before learn about the effect of olfactory indicators on testing of acid and basic, we must learn about what do you mean by olfactory indicators, right? So basically these are the indicators which not change color but changes taste and smell. taste and smell. Okay, so olfactory indicators are basically those indicators which not change their color, but they change their smell and taste. Okay, so basically we use two main olfactory indicators. First is our onion, second one is our vanilla. Okay, for onion in case of acid, for base. Similarly for vanilla in case of acid, for base. Okay, so basically for acid, no change. For basic, loses smell. Okay, similar thing happen with the acid, no change, but for bases, loses smell. Got it? So it is the olfactory indicators for onion and for vanilla. For onion, it loses smell with the base but does not change with acid. Similarly, for other indicator like vanilla, it loses the smell with the basic but does not change with the acidic. Okay, now let's come to the artificial indicators. Okay, so let's move forward. So this is our artificial indicators, which is known as the pH scale, and where pH stands for potence of hydrogen, or more precisely you can say potential of hydrogen. Potential of hydrogen. Got it? So basically all those indicators which we're using only helping us to identify whether the thing is basic or whether the thing is acidic, but they were not capable to find out the intensity. Find out the intensity of acidic nature, of acidic nature, or of basic nature. Okay, so that's why we have to develop the pH scale, and basically pH scales is used for potential of hydrogen more precisely. Okay, so you can say the increasing numbers of hydrogen will be, the more will be the acidic. The more will be the acidic, whereas the less number of hydrogen will be, the less will be the acidic, or you can say the more will be the basic. Similarly here the less will be the basic. Okay, so here in this picture you can see that 7 is a neutral number. Total we having 1 to 14 and also beyond is several numbers. Okay, but 7 is a neutral state. Okay, and beyond this is acidic, and above is are basics. Got it? So here you can see the urine and the milk having a 6 pH, so they are the acidic. Coffee and beer having a 5, having a 5 basic, so they are acidic. Tomato juice having a 4, then it is also acidic. Vinegar having 3, acidic. Gastric acid having 2, acidic. Lead acid battery having 0, acidic. Hydrochloric acid having -1, acidic. Similarly, ocean water having 8 is basic. Hand soap having 10 is basic. Ammonia having 12 is basic. Bleach having 13 is basic. Lye having 14 is basic. Okay, so this is about the pH scale. You can remember it, or also you can say that if a substance having below 7 value, then it is an acid. Okay, below 7 value it's an acid, Above 7 value, it is a basic, and 7 value, it is a neutral form. It is a neutral form, or here you can say the pure water. Okay, so here we have finished the indicators. Now let's move forward. Acids. Acids are substances that releases hydrogen ions when dissolved in water. They have distinct properties such as sour taste, the ability to turn blue litmus paper red, and ability to react with metals to release hydrogen gas. Okay, so basically acid having several types of property with different substance. Okay, so let's have a look on these properties first. Our first reaction is acid with metal. Okay, so it's always give hydrogen gas and respective salts. Let's take an example like zinc. Zinc, which is a metal, reacts with HCl. Reacts with HCl. Here Zn is zinc. Here Zn is zinc. HCl stands for hydrochloric acid. Okay, then it will give this one plus this one. Okay, this is known as zinc chloride. Zinc chloride, which is a salt, and this is known as hydrogen. This is known as hydrogen. Got it? So whenever acid reacts with metal, it always gives hydrogen gas and respective salt. Like zinc react with HCl, provide zinc chloride and hydrogen gas. And by putting candle, you can hear pop-up sound to evaluate hydrogen gas release. Okay, so basically you can say if this is the place where you react hydrogen with metal, and if you put your candle nearby it, then the candle will produce pop-up sound, and this pop-up sound is an indication that the hydrogen gas has been released. Got it? So it is our first situation. It is our first situation. Okay, now let's move forward. Second condition is when acid reacts with metal carbonate. When acid reacts with metal carbonates, always give respective salts, carbon dioxide gas, and water. Okay, like take an example, sodium carbonate reacts with hydrochloric acid, or you can say the HCl. The product will be sodium chloride, CO2, and H2O. Sodium chloride is a salt, CO2 is carbon dioxide, and H2O is water. Got it? So if acid reacts with the metal carbonate, these will be the products like respective salt, carbon dioxide, and water. Here, if this is a place where you're doing this experiment, okay, just put a bowl of lime water, and put a string from this beaker to this bowl. Okay. And when the experiment will be taking place, you will notice that this bowl lime water is turning into milky. Okay. And when it's happened, then just note down the carbon dioxide is releasing. So you can say, you can check the release of carbon dioxide if this lime water start turning into the milky. Okay. So this is the second reaction which we had to discuss. Got it? Now let's move forward. Our third reaction is acid reacts with metal. Here you can say hydrogen carbonate. Yeah, hydrogen carbonates or hydrogen biocarbonates. It is the third condition. So remember, same products will be received, like metal carbonate. Got it? So if in the third condition you're reacting acid with the hydrogen carbonate, which is also called as the hydrogen bicarbonate, then you will receive the same product as the metal carbonate. Got it? Now let's move forward. These are types of acid. Basically, mineral acid are inorganic dried form minerals like the hydrochloric acid, the sulfuric acid, the HNO3 nitric acid. Okay, and these acids are used for various purposes, like your HCl is used in stomach or already present in stomach, also used for dyeing purposes, also used for disinfects and some other purposes. Okay, whereas sulfuric acid is used for cleaning metals, factory purposes, thereafter various chemical uses. Thereafter your nitric acid is basically used for fertilizers, explosives, and TNT. TNT is basically used in some other purposes other than the explosives. Got it? So these are for the mineral acids. Now the organic acids. The organic acids are the acids which contain carbon atoms bonded to hydrogen and oxygen atoms. Basically, you can say if it's a carbon atom, they are bonding with hydrogen and oxygen atoms. Okay, like the vinegar and the citric acid, and they are formed naturally. Got it? Now, a strong acid, the acids which completely dissociate into hydrogen ions. Okay, so you can say if this is your acid and this is your water, basically. Okay, so when you pour your acid into the water, then your acid should be dissociate completely into the water. If it is happening, then the acid is very strong. Got it? But if it is not happening, the acid is not so strong. The more dissociation of hydrogen atoms in the acid will be, the more strong the acid. If it is less, the less will be the acid. Got it? So students, here we have finished about the acids. In our next lecture, we will continue with the bases and the salt of this chapter only. Okay? Till then, thank you.